Hey, Radiance here. In this video, we'll explore the full-stack implementation of an engaging feature, a scoreboard showcasing the most productive users. This video will be especially relevant if you are tasked with implementing near real-time data reporting or simply intrigued by the development of such scoreboards. While Increaser's codebase resides in a private repository, you can access all reusable components and utilities at ReactKit. Let's dive in. The goal of introducing this scoreboard is to foster a communal atmosphere in the app, signaling to new users that it's both active and flourishing. While the total work hours may not be the ideal measure of productivity, it provides a reliable foundation to start from. Our frontend is built as a static site-generated Next.js application featuring a dedicated community page for the scoreboard. This page primarily consists of two components: Manage Profile and Scoreboard. By default, every user is anonymous on our platform. While the scoreboard includes these anonymous users, their names and countries remain hidden. The Manage Profile component is specifically designed to enable users to make their profile public and edit details like their name and country. At the beginning of the Manage Profile component, a title is displayed, followed by the Manage Privacy component. This component features an intuitive radio input allowing users to select between a public and an anonymous profile. The interaction with our API is encapsulated within the Use API hook. For insights on implementing a TypeScript backend effortlessly, refer to my video here. Additionally, we perform an optimistic update to the user state, enhancing the app's responsiveness. Upon successful operations, we invalidate the scoreboard queries, triggering a refresh to ensure the scoreboard reflects the updated user profile. Below, we present a preview of the user's appearance in the scoreboard. For an anonymous user, this includes a gray flag and the label anonymous. Conversely, for a public profile, an edit button is displayed, which activates the public profile form component. In this form, we extract the user's name and country from the state and assign them as default values to the use form hook from the React hook form library. Upon form submission, the use update user mutation hook updates the user profile. The user's name field utilizes a standard text input component available in ReactKit. For selecting a country, we employ a custom-made combo box that allows users to choose from a list of all countries. For details on creating such an advanced input, explore this video. In the scoreboard component, we leverage the Use API query hook to fetch the user's leaderboard from the past week from the API. The query-dependent component acts as a wrapper, displaying different components based on the query state. During data loading, a spinner is shown. In case of a query failure, an error message is displayed. Upon a successful query, the Scoreboard Table component is rendered. Updating the scoreboard in real time presents significant expense and maintenance challenges. As a more practical solution, we update the scoreboard every 10 minutes. The time of the last update is displayed using the last scoreboard update component. To ensure the time display remains current, the use rhythmic render hook is employed to forcefully re-render the component every minute. For displaying the user list, the scoreboard table component is employed, combining a flexbox element for list organization with CSS grid for arranging content within each header and user item row. On smaller screens, the column that displays the average block duration is omitted, as it deemed a less crucial metric. The content is wrapped with a separated by line component from ReactKit, a flexbox element that applies a bottom border and padding to all child elements, excluding the last one. This component is especially advantageous for delineating content with a line, as demonstrated in our scoreboard, where it separates the header from the user list. Firstly, a header is rendered within a CSS grid row component, followed by a list of users in a flexbox vstack component. We utilize the order utility from ReactKit to sort users by their daily average. Subsequently, we iterate over the users, displaying their data. The scoreboard display name component presents the username along with their country flag. Additionally, the format duration utility from ReactKit format the duration of the user's average block and daily average. To emphasize the current user, we compare the myPosition prop with the current index. When these values match, the outline component is rendered. This component utilizes the absolute outline CSS utility, which creates an absolutely positioned element. The size of this element matches the parent element's dimensions, with additional specified offsets. Having addressed the front-end components, let's shift our focus to the server-side implementation. To refresh the scoreboard every 10 minutes, we employ an AWS Lambda function, which is triggered by a CloudWatch cron job. This setup is configured using Terraform. Each time the Lambda function is triggered, it executes the sync scoreboards function. This function retrieves all users from the database who have non-empty sets and were updated within the time frame corresponding to the scoreboard period. While the frontend displays only the scoreboard for the last 7 days, later we could add scoreboards for longer periods such as 30 or 90 days. For these reasons, we utilize the scoreboard periods array, which currently contains only the week period. Scoreboards are stored in a DynamoDB table, with the primary key set to the scoreboard period. To expedite scoreboard queries, we duplicate user profile data directly in the scoreboard record. This strategy allows us to bypass querying the user table for every user in the list. However, this approach necessitates updating the scoreboard record each time a user profile is modified. Also, this could be accomplished by monitoring user items updates via DynamoDB streams. We opt for a more cost-effective solution. We'll incorporate this update logic within the endpoint responsible for user profile updates, as it's the sole avenue through which users can modify their profiles. This process involves iterating over each key in the input object and verifying if it's present in the scoreboard sensitive user fields array. This check is performed using the intersection utility from ReactKit. Should there be a profile change, we also iterate over every scoreboard to update the user profile data accordingly. The query for the scoreboard is straightforward. It involves taking the scoreboard period as an input and returning the corresponding scoreboard record. Additionally, we calculate user's position in the scoreboard, which is then displayed on the frontend. That's all. If you found this video interesting, please like and subscribe. Become an effective 10x programmer with my productivity app at increaser.org.